Building a Java project doesn't seem too bad at first glance. You just call javac on your source files and it spits out some class files. You can also copy over resources like images and strings. For distribution, you can jar up your class files and resources and you're done, right? Well, you might also want to generate some documentation. Running some unit tests probably sounds like it would be a good idea as well. If you're getting really serious, you might even want to run multiple sets of unit tests, including integration and acceptance tests. Then, assuming those tests pass, you might want to deploy your jar to a repository. This is starting to sound like it's a lot of work to do by hand, but not impossible, right? Or you could write a shell script that would automate this process. It'd be messy, but it's doable.
Android apps, on the other hand, are beasts. The Java source isn't compiled to standard Java bytecode, but to custom bytecode for the Android runtime. Android has 3 different types of resources that all get packaged differently. There's an additional wrinkle in that the resources that you define need to be pooled together with resources coming from your included libraries. And the identifiers of all those resources need to be known beforehand before anything else gets compiled. Also, Android apps must be cryptographically signed. When you put all that together, it looks something like this. Now, consider you might want to build both debug and release versions of your app. You might also want to build free and paid variants. The point is that the process of building an Android app is not something we can do by hand. It's not even something that we can do in a shell script. We need a more robust solution. That solution comes to Android in the form of Gradle.